Welcome to Unite Now, where we bring unity to you, wherever you are.
Welcome to today's session. Again, we are going to be making a flag shader with shader graph today. So who's this voice that is speaking to you through the machine here? My name is Andy Jevsevar. I'm a certified Unity instructor and the director of technology at Kairos XR. We build AR and VR experiences for training and education. But I'm not the only one here today. I'm also joined by James, Ethan, and Rodrigo, and they are going to be helping man the chat, answer all the questions, and provide you with all the answers that you need to successfully complete this challenge. So there is a team that is making this happen, and as I mentioned, the team here is going to be responsible for answering all the questions that you may have. So we really encourage you to take advantage of that during today's session. So what are we going to be doing today? We have a few housekeeping items up front, talking about what these sessions are for any first-time visitors. We're going to be talking about the Unity version we're going to be using, what you can expect. And then we're going to dive in. Most of today's session will be spent in Unity, working through challenges, again, asking questions, getting those questions answered, with the goal of building a flag shader using shader graph. We have a few additional areas you can explore at the end, and then we will do a little wrap up. So that is what you can expect today. One note regarding the session is you will see these three icons, and I'll call these out when they come up, but highly recommend that you follow along these icons. So if we see a stop sign, that means that I'm going to be doing a demo. I encourage you to watch as I do the demo. Those demos will be followed by a green thumbs up. And that means that it's your turn to open up your Unity and dive in, work on the challenge. And then we'll have the question mark is explore. So you can kind of dive in, explore a little bit more, continue to ask questions, and get those answered. I'll call these out as they come up, but do keep an eye out for them. If you are joining us for the first time, we do recommend this Zoom layout so you can see the chat. You can just have this on your screen. And again, if you have a question, use that Q&A webinar panel to drop that question there. We'll get those answered. Anything else, a comment, feel free to drop that in the messages in the chat. Hey, we may have a poll or two. I will let you know if and when those come out. Worth noting that these sessions are recorded, so that means you can watch this back afterwards. It also means that there are other sessions if you are new to the Learn Lives, the Learn Live sessions. You can catch up on old recordings. You can go through the library there. There's lots of great recordings at this point. We are going to encourage you to download the Unity project and follow along. You get the most out of these sessions when you're actually working through the challenges, asking those questions, and getting the answers. Again, the ground rule here is that topic-related questions or questions relating to the project, we're going to encourage you to use the Q&A panel for those. That just helps us organize them, make sure we get them all answered. Anything else, you can drop into the chat. So additional comments can be dropped in the chat. Again, this is recorded, so be respectful and be constructive. We are going to be using Unity 2019.4, the LTS version. Just so you know, this will be the version that we will use for all Learn sessions moving forward. So you can plan on using this session for the foreseeable future, or this version for the foreseeable future. We do have the bit.ly link here to get the assets if you've not already. We'll have a moment in the next few slides to download and set up the project. And again, this will be recorded so you can watch it back. James just posted the bit.ly link there in the chat. Thank you, James. Feel free to follow that link and get access to the assets. All right, so we are making headway through our agenda here. Let's go ahead and continue on. What are the goals today? Well, again, we want to make a flag shader with shader graph. So what does that look like? Well, you can see over here on the left that we will have a flag that is waving back and forth by the end of today's session. Okay. There are a few steps that we will take, and we will explore these more in a second. There are a few steps that we'll take to make this shader work. Do you want to just break this down into kind of the 4 steps that we're going to be following, right? So the first step is we're going to make this shader move our plane back and forth. Once we get the plane moving back and forth, we're going to take that same back and forth motion and see how we can apply this wave to it, right? So we're not moving the entire plane, but we're moving each vertice of the plane. Then in step 3, we're going to mask one end. So as you can see, this left edge is now static, and so it's simulating being attached to a flagpole, right? And the last step, the bonus challenge here, will be to add the texture, right, and actually make it look like a flag. So before we actually dive into the project, I do want to take a moment to make sure that everyone can set up the project and they have the asset package downloaded. So let's go ahead and do that now. Notice the green thumbs up in the top right corner. This means that it is your time to shine. Go ahead and go to that asset link if you've not already. And you're going to go ahead and download the shader graph assets. Okay, so let's take a moment here. Go ahead, download those assets. Let me know in the chat when you have those assets downloaded and extracted on your machine, and we will continue on to the next step. And if you have a question during any of this, again, use that Q&A panel to ask that question. We will get it answered there. We have a question right off the bat. Well, a few of you are continuing to set up those assets, get those downloaded. Question right off the bat here is, what is a sine node and a UV node? We're going to hold on that one. We'll get to it. We do have a few challenges around those nodes, so we won't answer that right away, but we will answer that shortly. Okay, I'm seeing a few questions regarding the Unity version. So again, we are going to be using Unity 2019.4 moving forward. This session was previously ran using 2019.3, so you may be able to get away with it. But again, Unity 2019.4 is going to be the preferred version moving forward. So getting the thumbs up here, quite a few of you have mentioned that you've got these assets downloaded, so let's continue on to the next step. Once you have that asset package downloaded, you're going to want to open the Unity Hub and create a new project. Now, again, we are going to be using Unity 2019.4, the LTS version, so go ahead and choose that version and select the URP template. Okay, this will just set up your project to use the universal render pipeline right off the bat. Give it a name, set a location, and hit create. And let us know when you have that project created on your end, and we'll continue on. And then while you are setting up that project, see another question coming in here. What is the longevity of an LTS stamped version of Unity? Keep me honest here, Ethan, Rodrigo, and James. I'm under the impression that the LTS versions are 2 years. And I'm getting confirmation here. Yep, so the LTS versions are timestamped for 2 years. Seeing a few of you setting up this project, we're going to continue on to the next step. Again, if you have a question about setting up the project, feel free to use the Q&A and we will address it there. The last step in setting up this project for today's session, so that you can follow along, is you have the project created, you've downloaded the assets, go ahead and import the asset package right into your project. And you can just drag it in to the project window to do an import, and then import all. Okay, and then let us know in the chat when you are ready, and we will continue on. All right, getting the green light. Thank you, folks. So again, if you have any questions about those 3 steps setting up the project, feel free to drop those in the Q&A and we will address them there. But we have quite a few of you are ready to go, so let's go ahead and dive in. So we are going to dive right into today's first challenge here. So what we want to do, again, is we're making this flag wave. So we're going to take this in steps, right? We're going to break this down to a few concrete steps. And this is how you would start to do it when you're creating shaders on your own, right? You want to try to break things down into individual steps and work up. So again, for the flag, we know we need the flag surface to wave back and forth. But in order to do that, we just need to start by offsetting the position. right? And then we can kind of dive in and see how we can make that change across the entire surface. So with that said, we do have the stop sign in the top right corner. So I'm going to recommend that you watch as I do a quick demo here, and then we will turn it over to you in the next slide for you to dive in and work on the challenge. So with that said, I'm going to share my screen into my Unity editor. Let's check this out. Here I am. You should see my Unity editor here. I'm in Unity 2019.4. So this is the LTS version. And I have imported the project assets. I am using the universal render pipeline. Okay. You can tell that I'm using the universal render pipeline because my sphere on the bottom here and my flagpole are not pink. They would be pink if you haven't set up the universal render pipeline properly. But again, if you use that template project, you should be good to go. And we are ready to start making our shader. So if you have any questions about the setup, how to get to this stage, again, drop them in the question and answer and we will get them addressed there. What we want to do is we want to create a flag shader using shader graph. So step one is we need to create a shaders folder, right? It's important to stay organized. So in the project view here, I'm going to right click, create folder. I'm going to call it shaders. Okay. I'm going to open that folder up and I'm going to go ahead and create a shader graph shader. So if you go to shader, you have a few different options. Today we're going to be using the PBR, or physically based rendering graph. So I can select that. I'm going to give this a name. I'm going to call this the flag shader. You can name yours whatever you'd like. Okay, and now we have this created. We could go ahead and open it up. But a cool little tip here is if you right click right on the shader and click create material, it will create a material using that shader. So saves you a step there. Quick little shortcut. And we're going to go ahead and take this material. Again, this material is now using our custom shader. We're going to apply it to the flag. So the flag is this object here. Go ahead and drag this in. Lost it. Drag that in. And now you can see that our flag is no longer pink because it's not missing anything, but now it has our custom shader graph flag shader. All right, so now we want to open up the shader graph and start creating this flag shader. So I'm going to double click and that will open up the flag shader here. Something I'm going to do right off the bat here, whenever I'm working with shader graph, I like to reconfigure my layout. Right, so I was in the default layout here, but what I'm going to do is I'm actually going to go to the tall layout. Okay, and in this tall layout, what I can do is I can open up my shader graph again. I'm going to expand this window so I can see my flag over here on the left, but now I have most of my workspace in the actual shader graph view. So I recommend that take a second to set that up so you can see the shader graph and have lots of space to work with your game view over here on the left. All right, so what are we doing? We are creating a flag shader. And the first step that we want to do is we want to make this flag oscillate back and forth. So how do we access the position of this flag? Right? So you can see the flag right here in the game view. We want to access its position. So the way we access its position is we can, in the shader graph view, we can go ahead and create a node. Okay. And I don't necessarily need to know where this lives through the sorting here. I could look through the channels, but I don't need to know. What I can do is I can just start to search for it, right? I'm looking for position. Okay, so I'm going to create that. And it is going to create this position node. Now this position contains the position of each vertex of our object. Okay, we're going to change this from world to object space so that it is relative to the object and not relative to the world. Okay, and now we have this position. We could just connect this right to the vertex position of our output or master output node here. But that's not going to do anything for us, right? That's just going to be exactly what we see on the screen here. We can save the asset and we can see that that's the case. What we want to do for starters is we want to offset this position. We want to start to make that position move. So how could we do that? How could we offset the position? Well, what we can do is we can grab this, we can drag it off, and we can drop it. Okay, and if I want to add something to the position, right, I could do that. So I can just hit add. Okay, and now I'm going to connect this one in. And I want to take a moment here because with this add, what we can do is we can literally say each of these vertices that is on our mesh, we can add some concrete value to it and offset it. So let's see what this looks like. What happens if we add 1 to the x value? Now if I save the asset, you can see that this actually shifted 1 in the x direction. Okay, you might be wondering why that's down. If we go back to the scene view here and I zoom in a little bit, we can start to understand why the way this plane here is oriented. So if I select a plane, you can see that the axis here is a little rotated. But you start to see the idea, right? We could shift this more, right? If I change this to 5, it's going to offset 5 in that x direction. So if I save that, boom, it's shifted down. So this starts to give you a good idea of what's happening, right? We're taking the position, again, the position of our mesh, and as we render it to the screen, we are offsetting it 5 units in the x direction. And we can see the result of that here. You can see the orange outline of the flag. Notice that's where the game object still is located. The shader, again, is just where it's being rendered, right? So if you had a collider on here or some other game logic, that would still happen in the original position. But the shader is where the material gets rendered. So this is great. We're moving it up and down. We could adjust this more. We could explore. But what we want to do now is we want to have it move back and forth. We want it to oscillate, right? A flag isn't just frozen in time. It's actually going to be oscillating. So how do we take this same logic that we're working on here and oscillate, right? So right now we are just adding a discrete value. But what if we put something in here that was oscillating with time? How could we do that? Well, we can actually, I'm going to close this blackboard as well here. Let's see, just have a little bit more space. We can actually add time into this value here. So what I can do is I can right click, create node. I can look for one called time. Okay, so we have time. This is just going to be a counter, right? As your scene starts, this will just continue on and go from 0 up to as long as your game runs. But notice that with time, we have a few other options, right? We have a sine, cosine, we have delta and smooth delta. Sine is going to be that oscillating pattern, right? Sine oscillates back and forth from -1 to 1. Right? So if you're familiar with that trig, you may have learned in high school, the sine is a sine wave. And really what that does is, again, just oscillates back and forth between -1 and 1. And that's actually what we're going to want to use here. So what I can do is I can grab this sine output and I can add it here. Okay. Now we can see in the preview here that it is starting to oscillate back and forth. Let's go ahead and save the asset and see what this looks like. All right. So in our scene view now, the plane that we have added this flag material onto is now moving back and forth. Right? We've connected it to a sine time here. We've added that, and now it is oscillating the vertex position. And you can see that again in the game view. Okay. So we broke that down into a few manageable chunks. what I want to do now is I want to turn it over to you guys so you can go through those same steps, ask some questions. Again, a lot of the value in these sessions are getting your questions answered. So I encourage you to ask those questions. But I'm going to shift back to the presentation. And I would like you all to hit this green thumbs up in the right corner here and get started. So you're going to use the position node. You can use that sine node in there, and you can start to make this plane move back and forth. Okay. Again, ask any questions as you have them. We'll just take a couple minutes here. Let me know in the chat when you have set this up successfully, and we will continue on. So a couple questions while you guys are working here. I'm just going to continue to answer the questions. We have a question here asking if you should have learned something prior to today's session. So the thing that's really nice about these sessions is these challenges are set up on the Unity Learn site. So you can go there, you can do the challenges prior to today's session. And that gives you an opportunity to preview the material, go through a few supporting tutorials, and you can have that information coming into today's session. If you've not done that, no worries, you're still in the right place. But just so you know, you can preview the material on the Learn page. And that also means that you can review the material, right? We're going to try to get through this all today, but maybe there's a bit that you want to review. This session is going to be recorded, and you have the tutorials that you can revisit on the Learn site. All right, so we have a few more questions coming in. If you may not see the shader in the scene view, right? So there's actually a little toggle that you can, or you might not see it animating in the scene view, right? You can see the material, but as soon as you add that sine wave, you might not see it animating. There's actually a little toggle. So let me quickly jump back to my Unity editor here and make sure that you guys can all see that. In the scene view here, one of these drop downs right here has an animated materials checkbox. And so you're going to want to go ahead and check that. And so as soon as I check that, mine kind of smoothed out quite a bit. But again, in the scene view, one of the drop downs here with the skybox, fog, flares, and then animated materials. And if you have that checked, you should be able to see your shader working in the scene view. Actually, maybe I'll just leave mine open here so you can kind of see what's going on. Where is the flag scene? Good question. So if you go to project and you go to the Unity EDU folder and you go to the scenes folder, there should be a flag shader scene, and you can just open that up and it will be set up like that. Yep, so the scene that I'm using, again, once you've imported that asset package, if you go to Unity, EDU, go to scenes, and then the flag shader graph scene is the one that I'm using. Good question here regarding the sine time. Is it sending the same value to all three components of the position? So remember here that the position has three elements, right? X, Y, and Z. This is a three-dimensional space. We're taking something that is one-dimensional and we're adding it, right? And it appears that it's only moving back and forth on one direction here, right? It looks like it's just moving on the, I believe this is the Y of this object. This is actually a really good question. We can actually see that it is, I believe it's just moving back and forth on the Y direction. So I've seen this in the past. Well, let's actually make sure that that's the case. I've seen this in the past where it actually will move on all three directions. So the X, Y, and Z. Here it does appear to be moving only on the Y direction. We'll see here shortly how we could control each specific direction. So if we wanted to have it move back and forth in all directions, we could split out this position and control each one individually. So which shader did we create here? We created a PBR graph, right? So if you go into that shaders folder and you right click, create shader, you chose the PBR graph, which is physically based rendering graph. So how did I open the shader node editor here? What you can do once you've created that shader, you can just double click on the shader asset, and once you've double clicked on it, it will open it up in its own window. I went ahead and just shifted my windows around. I used the tall layout and then added the flag shader window here. But whatever layout you prefer is fine. We have the flag moving back and forth. Let's go ahead and dive in. One last question here. We see, how do you link the shader to the material? So when you have a material, you can choose your custom shader using the drop down. You can navigate to your shader graph and choose your custom shader there if you'd like. A shortcut to do that is to right click on your shader asset. And if you create a material from that, it will automatically create a material that is using that shader. So a couple answers there. What we're going to do now is we are going to take this oscillating motion, okay, and we're going to take it from this whole flag, right? The whole flag is just moving back and forth right now. What we want to do is we want to make this a wave across this object. So there's a bit of a leap here. So I want to walk through what exactly is happening. We'll go ahead and set it up in Unity, and then I'll turn it over to you to give this challenge a shot yourself. What we're going to do is we are going to look at this simple little demo here. On the left, we have the mesh, right? So imagine looking at the side of the flag here. I've just broken it down into 2 dimensions to keep it simple, right? We're taking in these mesh components as we move across the flag. We're going to do some manipulation to each of these vertices, and then we'll see the output. So again, we want to get this wave going. So let's see how exactly this would work. So one of the things that you'll first maybe try when you want to break this into a wave is you'll take the Y component, right? So this is going to be the up and down in this case. And you'll pump that component into the sine node, right? And what will come out the other side is the sine of this value. But notice in this case, if we have a flat mesh, like our flag is flat, that these zeros, each time you plug a 0 in, you're just going to get 0 out, right? And there's going to be no change over here. 0 in to sine, 0 out, right? And sine is literally just a math function. You can plug this into a calculator. Say sine of 0. Sine of 0 is always 0, right? So we can see that nothing has changed there. We're not going to get any sort of oscillation. But what if we used the x position? So we took this -2 value, we pumped that into sine, and we've got an output. Right? And you can literally do this with sine. You can say sine of -2, and that gives you a value of -0.9. Now we're taking the x value here, pumping it into sine, and pumping it out to the y value. As you move across, you can start to see how this is going to create a flag-like motion, right? Put -1 into sine, you get -0.8, 0, 0, 1 is 0.8, and 2 is 0.9. So you can see as this pattern continues, we are going to get a oscillating wave. I'm going to jump back into Unity. Again, I've got the stop sign in the top right corner, so I'm just going to recommend that you watch. I'm going to do a quick demo. I'm going to set this up and then turn it back over to you so you can ask the questions and try this out on your own. And this is the crux of today's challenge, right? So, continue to ask those questions. We want to be a resource. We want to, kind of break this down. This is going to be the crux of today's session. Okay, let's see where we are. We have a position, and we are simply adding a sine value to it, and it is getting pumped out into the vertex position. We can see it's going back and forth over here. Now, again, we want to make this oscillate. So how could we make this oscillate? So I kind of hinted at it in those slides. But what we want to do, and I'm actually just going to take some of this away for a second so we can break this down. Let's just take this add away, right? What we want to do, the first thing we want to do is we want to take our position. We don't want to affect all 3 values at the same time, the x, y, and z, right? We want to be able to split this up. So what we can do, we can drag this out, okay? And I'm going to take this into a split node. What the split node is it takes a value, right, an input that has multiple, in this case 3, and breaks it up into its relative components. Okay, So X, Y, and Z are going in, and now we can access X, Y, and Z individually. Okay. So what we're going to do is we are going to manipulate either the X, Y, or Z. We are going to then combine them back together and put them into the vertex position over here. Okay, I'm just going to collapse that. So what we can do is we can take our X, we can take that straight across, and we can take our Y, and we'll see how we can manipulate each of these in a second to actually get that oscillation. So what I've done is nothing right here, right? I've set this up to split, and then I've just recombined it, right? That's not exactly what we want to do. What we want to do is we actually want to take a bit of the split here. Specifically, we want to take the Y value of the split, and we want to have our sine time work on that so it oscillates across the Y values of our mesh. Okay, so I'm going to go ahead and just set this up. I'm going to walk you through what I'm doing, why I'm doing it. So again, I'm going to take this Y value. I'm going to bring this down, and I'm going to put this into our add node. Okay, I'm going to leave time out of it for a second, just so we can see exactly what's happening before it gets animated. So taking the Y value, I'm adding a value to it. Right, so our Y value from our mesh, we're adding a discrete value to it. I'm going to take this, and I'm going to put this into a sine node. Okay, again, this node just takes the sine of whatever goes into it, right? So we're taking our Y value, in this case, we're adding 5 to it. We're taking that value and taking the sine of that value. Okay, so now we want to take that value and we want to pump it back in. So if I put it back into Y, let's see what happens here. So I'm going to go ahead and save the asset, and let's see how things are looking. Okay, things are not any different, right? Well, you can see they're a little different. It's just moved, it's offset 5 in the Y direction. Okay, so we could bring this down just to see exactly what's happening. This is set offset at 5. If I offset this at 1, it should move forward. Right, so now we're offset 1. Right. Again, this value is going into sine, so it's going to be going back and forth between 1 and -1. So this is fine. What we can do now is instead of adding a discrete value, we can take our time value, we can add that in. Okay, we can save this asset. Let's see what's going on. Okay, it's going back and forth, right? But we're not seeing that oscillation across the surface. Again, this is because we are taking that Y value, which in this case is just 0 across the entire surface, and we're taking sine of 0 and adding it back in. So we're getting that same behavior that we had before. But what we can do is we can take that, we can actually plug it back into the Z value here. Oh, yep, let me just adjust this. There we go. Okay, so let me describe, or let me try to explain what just happened there. So what we can see now in the scene is we can actually see we are getting that oscillating motion, right? This is what we were looking for, right? We can see it's kind of extreme right now. We'll work on tampering it down. But what we have is a flag that is oscillating. So again, what's going on here? We are taking the Z value, and let's just click on this object here so we can see again where its relative axes are. We are taking this Z value, right, which is this blue axis. So as we move across the surface, we have Z values going from over here to over here. Again, each vertice. Those Z values are getting pumped into this add. Now time is being added to them, and they're going through sine, right? So the time just makes it so that it's shifting as the scene goes on. But all we're doing is we're taking these z values, we're pumping them into sine, right? This oscillates them back and forth between 1 and -1, which we can see here, right? Some of these values are getting +1, -1, +1, -1, everywhere in between. We take that output and we are plugging that into the y, right? So we're only affecting the y value of this mesh. So as we can see, the green axis, which is the y-axis, is the one that's being affected. The other ones, x and z, are just going straight across, right? We're not doing anything to them. We're only affecting the y-axis. So this, again, is kind of the trickiest part of the project. So I do want to take a moment to help answer any questions and elaborate on this. But while I'm doing that, I'm going to turn it back over to you so that you guys can take on this challenge and set this up in your scene. Again, we have the green thumbs up in the top right. So I want you guys to take on this challenge, try to set that up. Again, ask questions as you have them so we can do our best to answer those. All right, a couple of good questions coming in here. Thank you for those. Why are the X, Y, Z stated as RGB in the splitter? The splitter just has those kind of default values. RGB, a lot of the things you do in shader graph are color-based. So just RGB, again, it is correlating to X, Y, Z. Why does the flag have invisible parts while moving? This is a good question because this is just a simple plane. As we start to move those vertices around, we're actually going to start to see the backside of the flag as well, right? And this right now is just a one-sided material. So some of the invisible things that you'll see is just because that back part of the material is coming through. When we adjust the amplitude down, we'll be able to kind of figure this out and make that less apparent and look more like the screenshot here. So should you make it double-sided? You definitely can make it double-sided. I kind of leave that for a last step. Feel free to toggle that on in the master node. You can just enable that double-sidedness, and that will help. Feel free to go ahead and do that. What I'm going to do is I'm going to jump back to the editor. So you can see my shader graph here. I'm going to zoom out a little bit and adjust my nodes a little bit. Quick pro tip for keeping your shader graph area clean is you can always move this shader to the right, this master node. I find that moving the master node to the right as you're going, you'll kind of continue to spread out and not overlap too much. Okay. It's always best to read these things from left to right and just keep the master node over by itself, and that will keep your shader graph relatively organized. A question about world space versus object space, right? So if you take the object space versus world space, so object is relative to the object. So as you can see here, our object is in this area. So the vertices that you gather will be relative to that object's space. What does that mean? Well, it means that the very center vertex here is going to be 0, 0, and as you go out to the left, you're going to have your -1, -2, 0, and as you go up, you'll have 1, 2. Versus if you're doing this in world space, it's going to take the origin of the scene, right? So again, it's useful for some different shader effects. For a flag, we actually want it to be relative to the object itself, so we're going to leave it there. But you can definitely explore object versus world space. I'm just going to review this one more time, and then we are going to continue on. The challenge here, right, the real crux is using the z value in this case as the input for our sine. Right? When we use the z value as the input for our sine, because the z values are changing across the surface, right over here, they're like -1, 0, 1, 2, 3, 4, as you move across. Since these values are changing, when you pump those into sine, you're going to get different outputs, right? Those different outputs, as you plug them back into the y value, are what allow this to oscillate across the surface. Before, when we just had the y connected here, because y is the same across all this, right? The y value of these positions on these vertices is just 0. So if we take sine of 0, we just get 0. We don't get anything interesting. Right? So the trick here is taking the z value as the input for the sine. And that allows you to get that change in oscillation across the surface. We have the flag, and we have it oscillating now. What we want to do is we actually want to attach one end of this to the pole, right? So as you can see here, this end is completely stationary, while this end is freely flapping. So this is going to simulate it flapping in the wind while this side is attached. So how do we do that? I'm going to jump back into Unity. We're going to set this up. Okay. And the way we want to set this up is we want to take our effect, right? We can see that out of this sine right here, this is where our effect is happening. And we want to nullify the values, right? Make them 0 them out on one side, and we want to have them be full effect on the other side. So we want to go from 0 on one side to 1 on the other, right? So how could we do that? What could we use that maybe goes from a value of 0 on the left side to a value of 1 on the right side? And whenever you're thinking about something across an entire object, one of the tricks you can use is you can use the UVs, right? The UVs are inherently values from 0 to 1 across the surface, right? Especially when you're using a plane, the UVs are a great way to mask something on one side and let it be fully functioning on the other. So let's see how we can use a mask or UV to mask our flag to make it attached to the pole. So what I'm going to do is I'm going to create a node. We're going to look for the UV. There it is. Okay. We need to split this, right? There's 4 values in the UV. So let's bring this out into a split. Okay. I'm going to move these down a little bit. And again, what we want to do is we want to take these UVs and we want to multiply them to our sine, right? These values are literally going to be 0 on one side and 1 on the other. Just to see that, one of the cool things you can do, if I just grab one of these UVs and I drag this out and I type preview, this gives you an idea of what the values are, right? So on one side, it is black, and on the other side, it is white. Black values correspond to 0, and white values correspond to 1. You can see there's a gradient in between. So we have this UV is going to be 0 on one side and 1 on the other. This is exactly what we want. Now we can take this and we can multiply it with our output of our sine before it goes into our combined node here, and we should be able to mask this. So let's go ahead and check that out. I'm going to drag this up into a multiply. I'm going to multiply it with this one here. Okay. And here's where, again, organization is going to be helpful. So I'm just going to drag these over here like this. And I'm going to pump this one into the Y value there. We don't need this preview anymore. We were just looking at that. So I'm just going to delete that. And then now if I save, let's see what we have. All right. So we are close. We can see that the, maybe you have to see from your angle, but we can see at the top is still freely moving, but the bottom is the side that's now masked. You can see that bottom edge is what's masked. So we didn't get the right UV. We want to get the UV that will mask it along this side. So let's just try the next one. Drag that in. I'm going to save it. Okay, let's see what that looks like. We can see that's just the opposite side. We are now on the vertical, which is great. We just want to flip this. So the way you can flip this is you can do a what's called a 1 minus node. And that literally just takes 1 minus the value going in. This has a preview on it, so you can see what that looks like. I'm going to drag that in there. I'm going to go ahead and save that asset. Okay, and then now we can see that it is successfully masked on one side and it is free to wave in the wind on the other. Okay, so one of the things that we'll want to do as we continue to build this out, right? We've got the core of our flag set in place. We can see the amplitude is quite quite hefty, right? It's a big amplitude. So how could we reduce the amplitude? We can just create a new value. We can actually do it in the Blackboard. We haven't used the Blackboard yet. What this does is it allows us to expose variables into the inspector. So I'm going to create a vector 1. We'll call this amplitude. By default, let's say that it is amplitude of 1. We'll take this. This is just a value. And where we want to address the amplitude is outside of the sine wave. So this value is coming out between -1 and 1. We can go ahead and multiply that. So let me show you what that looks like. Multiply these two together. Okay. And again, we can just move things to the right to stay organized. Go ahead and save that. Shouldn't make any change immediately. But what we've done, because we made this an exposed variable, is if we look in our inspector over here, we can actually adjust the amplitude. So if I went down, say 0.25, we can see that in our scene, our amplitude is a little bit more reasonable, and we could adjust that to our liking. So I'm going to turn it back over to you. This is, again, the challenge that we wanted to get to. So I'm going to open back up for questions and get an opportunity for you guys to try this out on your own. Okay. And while you are working through this last challenge, I do want to emphasize that this is available online. So we're going to have the recording. So if you'd like to go back through and watch the recording, feel free to do that. These challenges and corresponding tutorials, right? Maybe some of these nodes are new to you. You'd like to learn more about them. There are corresponding materials and tutorials that you can follow and learn more about all these individual components and how it all gets combined to create this flag shader. So, if you would like to review or go back and learn more about any particular node or step here, I really encourage you to check out the Learn site. You can review all the information there. So do you want to call that out? Yep, so to reverse the mask, you can use the 1 minus node. Again, that just takes 1 minus whatever the input value is. So that's kind of a nifty way to invert things. Right, and then would this work on a flag sprite for a 2D game? That is a great question. I do not, in a 2D game, I question whether you could access the third dimension in the shader. I know there's some specific 2D shader graphs. So you could create a flag effect. I don't know if it would be the exact same flag effect that we have here. You definitely need to check out the 2D graph for that. But it's a great question. Right, and how do you change the speed? Great question there. So the speed, or in this case, we call it the frequency. I'm going to jump back into Unity. I'll show you that quickly, and then we will do a quick wrap up here. So where you would adjust the speed is you would want to increase this time value, right? So just like we created an amplitude, if you create one called frequency or speed, and you drag it in, and then you want to multiply this time with that frequency. And if you increase the value here, you increase this time value, it's going to speed things up. Okay, so that is where you would adjust the speed. Great question. The challenges and the tutorials are online, so I encourage you to check those out. The last challenge here is kind of a bonus challenge. Once you have the flag waving, you can add a texture to the flag. And there's a texture included in the project. So that's a cool little bonus challenge for you. Again, these steps, as well as the solution, are on the Learn site, so feel free to check those out. We've covered a lot here today, right? The crux of this flag is definitely getting that oscillation going with the sine, so we did cover that. Again, continue to explore. The best way to learn this is by kind of, what happens if you plug the X node into our sine versus the Z node. Right? You can start to get an idea of exactly what's happening by exploring. So with that said, there are some bonus challenges. If you are looking to expand your shader graph knowledge, the best way to do it is just try to create some more effects, right? So there's a really great shader graph library by Andy Touch. It's got liquid shaders and portals, and you can do layered shaders, so mud or snow-covered rocks, dissolving shaders, holograms, and you can see all these different shaders here that are all created with shader graph. So trying to recreate those is a great challenge, a great way to improve your understanding of the tool. There are quite a few other ways that it's being used, right? This fish is very similar to what we have with the flag. There are a few additional videos on YouTube you can check out. Learn Site's definitely a great resource for all this stuff. But there's a lot you can do with shader graphs. So if you are looking to learn more, try to find a shader and try to recreate it yourself. That is the best way to learn. Covered a lot here. We have a Learners Connect group. We'll drop this link. So that you can join us there. I see your request to see the Unity screen. I'll jump back into that in just a second. But this Connect group is where we can continue the conversation outside of these sessions. And then once you've completed the flag, this is a really cool opportunity. You can actually share some of your work, right? Post a screenshot or a video, and you can see what the other learners are doing, right? What everyone's creating, and where you can actually take this. There's a lot you can do with this simple flag shader. You can take this to the next level. So with that, I thank you. Again, my name's Andy. If you'd like to connect, you can find me there at that bit.ly link. I will open it back up to Unity, so I'll stick around for a few more minutes just so you can see that completed shader. If you'd like to look and ask a few more questions, feel free. But again, thank you for joining, and we look forward to seeing you in the next session. Thanks.